In this video you will learn how to create a mouse cursor that clears itself before drawing itself again. So it's actually like a real mouse cursor, and also learn how to process mouse left, middle and right button clicks. Alright, let's get into it. Now that we can read from the mouse PS2 port and display the values on the screen, it would be handy to actually have a mouse cursor or a mouse pointer rather than just displaying an A on the screen wherever the mouse position is. So to get started, we'll head on over to mouse.h and we can define an array which tells our drawing function, our mouse pointer drawing function that we're going to create, it will tell it which pixels to turn on and which pixels to turn off. So uint8t mouse pointer equals curly brackets. And alright, we're going to be making it so each bit signifies a pixel, and we're going to make it 16 bits wide and 16 bits high. And that means we need an array with 16 bytes. So we could do it like this: 0b000000, comma, and we can just copy that and paste it, and then copy and paste that 7 times. 1, 2, 3, 4, 5, 6, 7. Actually, we need to copy that another 8 times, so we'll just do that one more time. So we have 16 across and 16 down, which will let us have a 16 by 16 mouse pointer. And this needs to be an array. Actually, now that we have that, we need to copy this, make this extern, and get rid of the initializer because we have to initialize it in a CPP file. So at the top of mouse.cpp, we can paste that new initialized array in there, and this one needs to be extern, or else when we include this mouse.h file from different places, then that array will be included multiple times, giving us a problem. Alright, so now we have our mouse pointer, we can actually define the shape of it. Now the sample shape I'm going to go with, to begin with, is just all ones for the first byte, and then 2 ones in the second byte. Then we have all ones for the third byte, and then 1 1 for the fourth byte. Actually, we need another one here. So we have 8 ones, and then 3 ones, and then 8 ones, and then 1 1. And then we have 7 ones, then we have 6 ones, then 5 ones, then 4 ones, 3 ones, 2 ones, 2 ones, 1 1, and 1 1. Now this is a fairly simple mouse pointer shape that I quite like. You can of course make your mouse pointer in any shape that you like, and even you could make it bigger than 16 by 16 if you want to. All of the general programming fundamentals will still be exactly the same. So now we can head on over into our basic renderer.h and we can add a new function called DrawOverlayMouseCursor. So void DrawOverlayMouseCursor. We need a point for the position, and we need a uint32 for the color. Right, now heading on over into basic renderer.cpp, we can create the implementation for that. So void basic renderer : DrawOverlayMouseCursor. And now we can start writing the function. We need to make sure that drawing the mouse cursor at the edge of the screen won't cause a page fault, and to do that we're going to make sure it doesn't draw outside of the frame buffer. And a simple way to do that is to limit the y and x maximum values. So to get started, we'll just do int x max equals 16, that's the size of our bitmap, and int y max equals 16, int difference x equals target frame buffer's width, take position.x, int difference y equals target frame buffer's height minus position.y. If difference x is less than 16, then x max equals difference x, and if difference y is less than 16, then y max equals difference y. And this will just prevent us from drawing it off the screen. Now we can do for int y equals 0, y is less than y max, y plus plus. For int x equals 0, x less than x max, x plus plus. Now we need to get to the bit of our bitmap, so that's pretty simple. We just do int bit equals y times 16, which is the size of our bitmap, plus x. And to get the byte, we just do int byte equals bit divided by 8. Now we need to check if that bit is set, so if 2 brackets mouse pointer, which we actually need a reference to, so we need to add another parameter, uint 8t pointer mouse cursor. So now we need if mouse cursor, and we'll just fix the basic renderer.h. We'll just copy this parameter here and paste it in. If mouse cursor indexed by byte and bracket 0b1000000, so that's 1 1 and 7 zeros, is shifted to the right by x modulo 8 in brackets. Now we have 3 brackets after that. So if this is true, we can now do put pixel, which we need a function for. We'll create that in a second. Put pixel position.x plus x, comma, position dot y plus y, comma, color. Alright, now we need to create this putPix function. Making a putPixel function is going to be slower than accessing the memory directly with pointers, but it will simplify things quite considerably. So now we do void basic renderer colon putPix, and we need the uint32x, uint32y, and uint32 color. And of course we need to declare this in the header as well, so we'll create this putPix function inside the header. There we go, void putPixel x, y, and color. We'll make it capital just to keep with the naming scheme of everything. So we'll change all of those to capitals, and now we can actually create the function. So we need to do dereference bracket uint 32t pointer bracket 1 bracket casted to a uint 64t target frame buffers base address plus bracket x times 4 end bracket plus bracket y times target frame buffers pixels per scan line times 4, exit those last 2 brackets, equals color. Alright, so that's dereferencing a cast to a uint32t pointer, and then we calculate the pixel address, and then we set it to color. Alright, now in mouse.cpp, instead of doing global renderer put char, we can now do global renderer DrawOverlayMouseCursor, and we need a pointer to our mouse cursor, so that's mouse pointer. And now we need a position, so mouse position. And now we need a color, so we'll just go out with white to begin with. Of course, this can be any color you want it to be. And now we can test that and see if that works. Now, as you can see, instead of printing an A to the screen, it now prints our custom mouse cursor to the screen. However, it is not clearing the old mouse cursor before displaying the new one, so we have this weird effect going on. So now we need to clear the old mouse cursor off the screen before displaying the new one. I just wanted to take this time to say thank you to my supporters on Patreon. Every little bit of support means the world to me. So thank you to my tier 2 supporters, That OS Dev and Bobby Addison, and thank you to my tier 1 supporter, Kenneth Looney. Your support means more to me than you could ever imagine. Thank you. And to do that, we need to store the position of the old mouse pointer. So in mouse.cpp, we can duplicate our mouse position point and change one of them into mouse position old. And at the end of our process mouse packet function, we can set mouse position old equals mouse position. We can create an array to store the pixels that were on the buffer before we drew the mouse cursor to the screen. That way, when we're going to clear the mouse cursor, we can set those pixels back to the way they were. So we'll create a uint32t mouse cursor buffer, and this will be an array of size 16 times 16, because that is the size of our bitmap, our mouse cursor bitmap. If you're using a different size to this, make sure that you update that accordingly. Now, I don't like to be using a fixed size buffer for this, because what if we want to support multiple different mouse cursors? Well, we're just going to have to do that for now, because we can't have a dynamically sized array until we get a heap implementation, which isn't far down the line, but for now we're just going to have to do it like this. Alright, we're also going to need to make a getPixel function. So that is a uint32t getPix, and we need a position, so uint32tx and uint32ty. Of course, you could always use a point for these values, but I'm using an unsigned int for x and y. Alright, now in basic renderer.cpp in our DrawOverlayMouseCursor, we can copy the contents of the frame buffer into the buffer we just made before writing to it. So, as we put pics, we also need to get pics, position.x, position.y, and mouse cursor buffer indexed by x plus y times 16, which is the size of the bitmap, once again, equals our getPixel function. Alright, now that we have that, we need to actually create a function for this getPixel function. So we have a uint32t basic renderer ::getPixel uint32tx and uint32ty. And now we can just copy this all up until the equals color, and in the getPixel we can do return and then paste that in and put a semicolon at the end. So that's pretty simple. Alright, so now that we're writing the contents of the frame buffer into the mouse cursor buffer before we write the mouse cursor to the screen, we can use these values to restore the buffer to the way it was before drawing another mouse cursor. So now we need another function called clear mouse cursor. So void basic renderer clear mouse cursor, and we need the position, so point position, and we also need to declare this in the header. And what we can do here is basically just copy this entire function body here, paste that in, and actually we could also copy this pointer to our mouse cursor, so we're only changing the bits that we need to. Paste that in as a parameter and change the header file as well. And now we can make it so it puts the pixel of the pixel inside of the mouse cursor buffer. Now in mouse.cpp we can do, before we draw the new mouse cursor, we can do global renderer clear mouse cursor mouse pointer mouse position old. I did make a mistake here. This needs to be position.x plus x and position.y plus y. Alright, now we can compile that and see what that looks like. Make sure you delete your lib folder and recompile everything, as changing the basic renderer.h header will corrupt everything else unless it is rebuilt with the new header. Now, as you can see, we can move our mouse cursor around the screen and it's all working properly now, which is good. One thing you might now notice is at the top left of the screen, we have overwritten the K at the very beginning. And that's because of the default state of the buffer being empty when we start. So something we can do to fix this is skip the first clear mouse cursor call that we make. So in basic renderer.h we can do bool mouse drawn, and in DrawOverlayMouseCursor we can set mouse drawn equals true, and then inside of clear mouse cursor we can do if not mouse drawn return. And of course, once again, we need to clean our project by deleting the lib folder and then recompiling everything because we've changed another header. And now you can see our K has been preserved successfully and our mouse cursor can move around the screen without a problem. One thing that we have left over from testing, however, is inside of mouse.cpp we have made it so that the mouse cannot go to the very edge of the screen so that it didn't cause a page fault, but we've created a new page fault security algorithm to make sure that we don't draw outside of the frame buffer, so we can now set it to width -1 and height -1, and this -1 and height -1 as well. So now the mouse can go to the very edge of the screen, and it shouldn't cause a page fault because we're not drawing outside of the frame buffer. So now, as you can see at the bottom left corner of our screen, we can put our mouse right to the very bottom right of the frame buffer, and it does not cause a page fault because we're not drawing any pixels outside of the frame buffer. Alright, so now one thing we have left to do is we have to make sure that we only flip back the pixels if they have not changed from when the mouse pointer was drawn. Because if we draw the mouse pointer and then we draw text over the top, but then we go to set the mouse pointer to what it was back before that text was drawn, it will overwrite it. So we only need to flip back the pixels that haven't changed. Now, of course, this isn't perfect because if what we draw is the same color as the mouse pointer, then it will be flipped back, but it will work in most cases. Further on in the series, when we start implementing an advanced graphical user interface, we can implement a feature to prevent this from happening, but for now, this is as good as we're probably going to get. Alright, so to implement this, we're going to need another buffer. So another UN32T mouse cursor buffer of size 16 × 16. But this one is going to have to be called mouse cursor buffer after, or something along those lines, because this is the buffer that we use after the mouse cursor has been drawn to the screen. So now in basic renderer.cpp, inside of the DrawOverlayMouseCursor function, we can set the mouse cursor buffer after to the pixel that we have placed in here. Alright, so we just copied this mouse cursor buffer setting function, pasted it again and changing it to after, and making sure we put it after the putPix call. Now, inside the clear mouse cursor function, we can put in a check to see if the pixel is the same as when it was before when we first drew the cursor to the screen. So if getPix position.x plus x position.y plus y is equal to mouse cursor buffer after indexed by x plus y times 16. And then only in this situation we put the old pixel back, which means that we're only putting this back if new data hasn't been written over the cursor. And remember, when recompiling, make sure you delete your lib folder so that everything gets recompiled, because we have changed the header again. Now that we have the mouse drawing functions out of the way, we need to actually implement a way to handle mouse clicks. Now, inside of mouse.cpp, inside of process mouse packet, we can check to see if left, right, and middle mouse buttons have been clicked. So in mouse.h, we can see that we have defined the PS2 left button, middle button, and right button bits. So inside of mouse.cpp, inside of process mouse packet, we can check to see if those buttons have been pressed. So after we draw the mouse to the screen, we can do if mouse packet indexed by 0 and PS2 left button. This means the PS2 left button has been clicked. If mouse packet 0, this is meant to be and PS2 middle button, then that means the middle button has been clicked, and similarly with the right button means the right button has been clicked. Now we can make it do something in one of these situations. So for instance, if we press the PS2 left button, we can make the global renderer print an A to where our cursor is. Put char A and mouse position .x and mouse position .y. Alright, so now as you can see, when I press the left mouse button, it prints an A to the screen where the mouse cursor is. Now if you look closely, when I press A, you can see the issue of printing a new value over the mouse cursor when it's the same color. So let's just print something of a different color to see how that reacts. So we can get on the right mouse button, we can make it so it sets a different color. So we can store the color of the global renderer. So UN32T color equals global renderer.color. Then we can set the global renderer's color to something like blue. So that's 0x000000FF. And then after we put the char, we can set the color back to what it was, just to restore the state. Color equals color. Alright, so it appears I've got the middle mouse button and the right mouse button bits mixed up. So in mouse.h, you just need to swap the bits of the middle and right buttons just to make sure that they line up properly. And also this blue is really hard to see on the black background, so let's set it to green. So that's 4 zeros, 2 Fs, and then 2 zeros. Alright, now as you can see, if I right click, then the A gets displayed completely. As you can see, that top curvy bit has been curved over completely, but if I left click and it prints an A that is white, then it doesn't do the whole thing because the color is the same as the cursor. Now, one quick and not very performant thing that we can do is remove the mouse cursor before each draw call and then restore it afterwards. But this isn't very performant, so you are welcome to do this if you would like to. It's just as simple as putting a clear mouse cursor before each draw call and then a draw mouse cursor after each draw call. But later on down the line, when we get to a windowing system and double buffering, there will be a much more elegant solution we can do. Alright, but for now, thank you for watching and I will see you next time.